Okay, so let's do part 2. And what I was going to do is start off by just doing a few reviewing problems, like from yesterday. So let's start here. And I want to practice those cubic formulas. And again, they're written on the board. And so we'll do some of these here. Okay, so, whoops. There we go. Ugh. Okay, so I'll do these 4 here to review what we were doing kind of yesterday. If you notice here, there's a factor of x here in all 3 of these terms. So one factor we can factor out is x. And then we can take a look at what's left after that. So if we take an x out here, I'm just thinking to myself, what do I multiply by to get x cubed? And I'm thinking, oh, x squared. Is that right? Makes sense? And so then I'm thinking to myself, what do I need to get negative 7x squared? And I'm saying all I have is an x here. And so I'm thinking I need a negative 7x. Okay? And then finally I just take a peek at this one and I say, okay, what do I need to get 10x? I have an x. It looks like I need a 10. And so that's how I do that. Now, whenever you're factoring, especially in this section here, you want to make sure you factored completely. This factor here is a prime factor. You can't break it down further. Does that sort of make sense? You just write it as x. But this factor over here, question is, can we factor it further? And yeah, some of you guys are saying yes already, because you notice there's 2 factors of 10, 5 and 2, that when you add them you get, well, they're both negative, you get negative 7, right? So you could do x minus 5 and x minus 2, and then finally there's this x sitting out in front. And now what we'd say is that this polynomial that we started off with right here is completely factored. Okay? Any questions about that one? Okay, so now let's take a look at this one. Try to give myself some space. Okay, so now I'm seeing a common factor, and when you're factoring you should try to find the greatest common factor, and I think I'll do this one up here. Okay? And so I think I noticed there's a 3y cubed, because there's a y to the 5th, there's a y cubed over here. This is 3 times 25. So there's certainly a 3y cubed. So that becomes my common factor, my greatest common factor, 3y cubed. Well, what's left goes on the inside of your parentheses. So again, you're thinking, okay, if I start off with this, what do I need to multiply to get 3y to the 5th power? Well, I have a 3 already, and I have y cubed already. It looks like I need a couple more y's. So yeah, I need a y squared. And over here, if I'm going to multiply, I need a 25, right? And I have the y cubed already. So I need a minus sign. And now I've done like the first step of factoring, but at this stage you need to consider your factors. This portion is prime already, but this part is not prime yet. I need to factor the difference of 2 squares, and this of course is what we did in chapter 1, so I'm not going to reteach all those steps in this lesson, but hopefully you recognize that this should break down to y plus 5 and y minus 5. And then out in front we have a 3y squared. And now we'd say this is factored completely. If you stop at this step, you're going to probably get half credit, even though everything you've done is correctly. I mean, it's correct. Does that make sense? So there's an emphasis on factoring completely. And even if you need to assume this always in this chapter, if you're asked to factor, you're expected to factor it completely. Any questions on that one? Okay, so that's one of our special patterns we had in chapter 1, and this one I think we get to the special patterns that we got to yesterday. Ooh, look at this big number. My guess is that this is 16 times some number. So I just use my calculator real quick and divide and see if 16 goes in there evenly. 686 divided by 16. Nope, that doesn't go in evenly. 14. Well, I need to find a factor of 6. I'm looking for a common factor. How about 4 or 8? Maybe 2. Let's write 2. Because that would give me an 8. And I know 8 is a perfect cube, right? 2 times 2 times 2 is equal to 8, right? My guess is that I might have an 8 left when I'm done. I'm just guessing. So if I divide this by 2, 686 divided by 2, well, that's 343. And 343, do you guys recognize that one? That's why I told you guys to write down the cubes yesterday. That is a perfect cube. That's 7 cubed. It's equal to 7 times 7 times 7. So I think I found my common factor. My common factor is going to be a 2. So this is 2 times 8 times b squared times b cubed, right? And this is 2 times 343 times b squared. And now I think it's fairly obvious what my common factor is. I have a 2, I have a b squared right here, and a 2, and a b squared. And look what's left after this. If you take the 2b squared out, and you factor that out in front of the parentheses, you end up with 8b cubed plus 343. Alright? Well, as we just discussed here and here, these are perfect cubes here. So now I'm going to use my perfect cube formula. And in case you can't see the board or whatever, the perfect cube for this one, it's going to be a cubed plus b cubed. And it's equal to what? It's equal to a plus b. And then you're going to have an a squared here and a b squared here and an ab here. This sign's always positive, and this sign's always like opposite, so minus. Alright, so when you're factoring this according to this special pattern, you need to figure out what a and b are. And what you have over here is not a and b. What you have over here is a cubed and b cubed. So the trick is, you need to say to yourself, well, if this is a cubed, then what's a going to be? 2b, right? There you have it, right? This is equal to 2 cubed, right? So this is going to be 2b. And I'll just show you real quick. If you do 2b and you cube it, you get 2b times 2b times 2b. Or not 2b. Oh. No one caught the reference? Come on, you guys are juniors. Aren't you guys reading Hamlet?
No, we read that so much.
Oh. Alright, that's a famous line from Hamlet. To be or not to be. Never mind. Okay, so back to this. 2 times 2 times 2 is 8, and b times b times b is b cubed. So that's correct. So now if this is b cubed, what's b? 7. There you have it. It's right up here, right? Okay, so this first factor right here, it's exactly what we have here. So we have 2b plus 7. Now what factors go here and here? Well, you just square both of these. That one, if you square it, you should hopefully do this in your head, you're going to get 4b squared. And if you square this one, you get 49. Okay, that's 7 squared. Okay. And then to get the middle term, the term that goes here, you just multiply the two together. 14b. And then this sign's always plus. Shh. And this sign here is always opposite. You see, you start off with a plus there. This sign's always opposite there. So it's a minus. And there you have it. Okay, so what I want to do is number 4. And after I do number 4, we're going to go ahead and work on our study guide for a little bit. And then I'm going to continue the lesson here after that. This time you have a difference of 2 cubes. So I'm going to write down the formula. It's up here. A cubed minus b cubed. It's equal to a minus b. And then once again, you're going to have an a squared and a b squared. And then you're going to have an ab. And this one's always positive. And this one's always opposite. So that means this one's plus. It's opposite of what you had here. Opposite. Okay, so as you can see, to get this factor right here, you have to figure out what a and b are. And again, on the left side, you don't have a and b, you have ab cubed. So the trick is to figure out what a and b are. Give myself some more room here. So if this is your a cubed, then what's a? And hopefully you can see, well, it has to be just w. And if this is b cubed, then what's b? Hopefully you're saying 3. Why are you saying that? Well, because 3 times 3 times 3 is equal to 27. Oh my goodness. There you go. Okay, so we found the a and the b. So now what you can do is start substituting into this special pattern up here. The first factor is exactly what we have here and here. So the first factor is w minus 3. This factor is easy. You just square. You just square whatever a is. So that's w squared. This factor is easy. You just square that one. 3 squared is 9. The middle term, you just multiply them together. So you get 3w. Now remember, this sign here is always positive on this special pattern. And then this sign, whatever you had here, is opposite. So that becomes a plus. And there you have it. Okay, so now we're going to take a break and we're going to go ahead and work on the study guide for a little bit. And so I want to pull that up real quick. And I want to show you which ones I expect you to be able to do now. So let me pull this up in our study guide, 2.4, and if you haven't done so already, you should be able to do 1, 2. We're going to skip 3 and 4 for right now. You should be able to do number 5. And we're going to skip, well, so let's do 1, 2, 5. What else can we do? Well, we'll do 1, 2, and 5. Okay? So I want to give you about 3 minutes to do those 3. 1, 2, and 5 you should be able to do right now. Okay? So number 5. Come on. So hopefully you recognize that there is a common factor of a 3b squared, right? So we start out by taking out a 3b squared. And then what's left? Well, to figure out what goes in here, okay, I hear a bunch of side conversations. Please, that's really rude to be talking when a teacher is. Yeah. Okay, so again, to figure out these spots here, just ask yourself, what do you multiply by to get that? And I notice I have a 3b squared already. I need a b to the fourth. Right? And then over here for the middle term, I need what? A 2b squared. And it looks like this is exactly what I have here. So some people feel like you should put 0 then because you have it all there. Well, what happens if you multiply by 0? You get 0, so it can't be 0. So it should be 1, right? So put 1 here. This needs to be plus, and this needs to be plus. Now, as we've been doing in previous problems, we have to factor completely. And if you examine this portion right here, that's not factored completely yet. Let me show you another similar problem, and hopefully we could apply this one. Hopefully we could apply this factoring idea. What if we had x squared plus 2x? Whoops. Back that up. 2x. Can you wait? Okay, so if we're factoring this one, what we want are two factors of 1 that give us 2. Well, if they're both positive, wouldn't that give us 2 here in the middle term? Well, if that's the case, this factors to x plus 1, and then x plus 1. And in this case, those factors are the same, so you could write this as x plus 1 squared. Well, this one is exactly that same setup as this, except for the powers are higher. This one's a 4, and this one's a 2. So it works the same way. So let me show you how this one's going to work, and I think you'll get it right after you see this. So instead of having x, we're going to have b's, of course, and what you're going to end up with is b squared plus 1 times b squared plus 1. You see there's the two factors that give you 1 and 1, and when you multiply it with b squared and b squared, you get 1b squared, and then you get another b squared, and when you add them, you do get the 2b squared in the middle. So this does factor, and it factors to this. So since these factors are the same, you get b squared plus 1, the quantity squared. Very similar to this one over here that I just did right here. So what we're doing is we're factoring polynomials with higher exponents than what we originally had back in chapter 1 when we had trinomials that were quadratics. And so with a slight modification, it's very similar to this idea. We could perform the factoring for this problem here. Ugh, that was ugly. Anyhow, hopefully that makes sense. So that helps you with number 5 on your study guide that we were just doing. Now, what about 3 and 4? How do we do those? Well, that's the thing I want to cover next on my PowerPoint, so let's get back to that. So factor by grouping. Now whenever you see this factor by grouping, usually what we have in mind is that there's 4 terms. And so take a look here. There's 4 terms. So this is no longer a trinomial, it's a quadnomial. That's a word I made up. Okay, so it has 4 terms. Okay, so typically what we do or try to do is factor by grouping. So what we do is we factor the first group and we factor the second group. And this is kind of like the AC method that we learned a long time ago. And so let me just show you that real quick. If you were doing the AC method, remember what we did. You have, like, if we had x squared plus, say 6x here plus 5. remember what you do when you do the AC method? Now normally we didn't do the AC method when there's a 1 here, but I'm just going to do this real quick. Remember what we did is we took this number, that's your A, that's your B, and that's your C. Remember what you do, you multiply the A and the C together, and so you get 5, right? And then you say, well, what two factors of 5 give me 6? And you go, oh, well, 5 and 1. Oh, hi.
Sorry.
No, that's all right. So you use 5 and 1. Then the idea on the AC method, remember, was to replace that term. So you could write this as x squared plus 5x plus 1x plus 5. Now let me just continue a few more steps, and then you'll see how this relates to this problem. Okay, so what do we factor out of these two terms? We could take out a 5x. So we get 5x here, and we end up with x plus 1, right? Now remember when we're doing the AC method, you always get this factor again. Some of you guys go, oh man, I don't remember that. Okay, so this is x plus 1, so we get x plus 1 again. All you have to do is figure out what number goes in front. And if you take a look back up here, hold up here, I had a little mistake. That's supposed to be x plus 5. Wait, I made it. It's supposed to be the common factor is this x, right? And then x plus 5. And first mistake I've made all day. So there's your second factor, it's x plus 5 again. And then this number needs to be a 1, right? And so now x plus 5 is your common factor, so that goes out in front. We can put that out in front. And that's gone. This is gone. And so then we get x plus 1. So that's what we did when we were doing the AC method. But notice what you have here. This is a polynomial with 4 terms in it. And that's exactly what you do here. It's the same idea. So it's a familiar idea. It's exactly what we're doing with the AC method, but now we're doing it with 4 terms here. It's almost like you skip this step and we go right to here. Make sense? So again, you factor whatever you can out of the first term. And it looks like to me we could take out an x squared. So I take out an x squared, and that would leave me with an x minus 3. Now, you can almost guess that you're going to get the same factor again. So I'm going to try it out. I'm going to try out x minus 3. And I say, okay, if I have x minus 3, okay, what would this factor here have to be? It would have to be negative 16, right? Because I need to get negative 16 and a positive 48. So let's try it out. Negative 16. Is that right? Negative 16. So if I were to distribute this, I'd get negative 16x. And if I multiply here, a negative times negative is a positive, so that's positive 48. So it does work. Now, we've got the first step taken care of. This is my common factor now. So that comes out in front. I'm just going to write it out in front. And what's left? Well, if I take this part out and I take this part out, I have x squared minus 16. So the question is, are we done? No, we're not done because this is a difference of 2 squares. So I think you're starting to notice that we have to keep factoring. This is going to factor to x minus 4 and x plus 4. And then finally this is going to be x minus 3. Wow. So that's how you do factoring by grouping. So now what I'd like you to do is go to your study guide, and I'd like you to try numbers 3 and 4. 3 and 4. So I'm going to give you about 2 minutes to do 3 and 4. I'll pause the video again. So I'll resume. Let's do number... Huh?
Last time I saw one of the videos on YouTube, she was talking the whole time.
She was talking the whole time. Oh my... Well, that's the team. All right.
Always just kissing around.
All right.
Hit him.
Hit him. Oh, good grief. Okay, so number 3. All right. How come I can't get my pen on? Okay, let's try this. All right, I'm there. Now I'll switch to this. Go. Okay. All right. You guys, I'll just write it down. You ready? Number 3. X cubed minus 3x squared minus 4x plus 12. Alright, so again, factor by grouping. What you want to do is look at these first 2 terms and see what you can factor out. The greatest common factor. I think it's an x squared. So I take out an x squared, and it looks like to me, you get x minus 3. Now, you can almost assume that this factor is going to come up again. So I got x minus 3. Go ahead. Top. It's more important, obviously. No, I mean seriously, if you guys don't want this class, go talk to Ms. Tovar. Tell her you want out of the class because you're not doing anything in here anyways. All you're doing is talking the full period. It's really embarrassing. I'm trying to teach, and you guys are talking, making a bunch of noise. Do you not sense that that's rude? I mean, I feel like I'm talking to little kids, and you guys are juniors in high school. And you haven't learned proper behavior. I mean, when a teacher is teaching, you guys shouldn't be talking. Okay, so we still need to figure out the number that goes out in front here. And all you need to do is figure out, well, what would you have to multiply to get this up here? It looks like to me there's a negative 4 missing. And so now I have this. I have x minus 3 is my common factor. So if I take that part out and I take this part out, what's left? I have an x squared minus 4. Okay, so now you need to examine this. This isn't factored completely. It's not prime yet because this is a difference of 2 squares. And so once again, the difference of 2 squares, a squared minus b squared, it factors to a plus b and a minus b. So that means then that this should factor to x plus 2 and x minus 2. And then this first factor here, x minus 3. And there you have it. This is completely factored now. Now number 4 is just like this, so I'm not going to do that one again, but let's move on to the next idea. What we need to be able to do is these problems. And the only difference on these problems is that you're going to use the principle of zero products. And we did that in the past in chapter 1, like when we had x minus 2 times x plus 5. You guys remember we did this principle of zero products before. What's that mean? X is equal to what? 2. X is equal to negative 5. So that's the same thing we're going to do here. You're going to factor first and then use the principle of zero products. So let's look at number 7. We can do it together here real quick. If I have x to the 4th power minus 3x squared plus 2 is equal to 0. Okay, so this is another one of those higher powered trinomials. And factors like normal trinomials. And so what you want to think of is How would you factor this if it were x squared minus 3x plus 2? How would you factor that? Well, you're going to factor this one the same way, except you're going to have higher powers. Okay, so this one you're looking for the middle term, right? So if we use negative 2 here and we use negative 1, if you were to add these, you get the middle term, right? And so this factors like this: x minus 2 and x minus 1. Well, so this is going to factor the same way, but instead of using x's, you're going to have x squares. Okay, so you're going to have x squared minus 2 and x squared minus 1. Alright, this is equal to 0. Now the question is this completely factored? Well, this once again is a difference of two squares. So that one's not done factoring. So this one's done because that's not a difference of two. That's not a perfect square here. And so what we're going to have here is x squared minus 2. And then when we factor this one, we're going to have x plus 1. And then we're going to have x minus 1 equal to 0. Now already use the principle of zero products. Okay? Now a couple of these are going to be real easy. This one gives us x is equal to what? Negative 1, right? This one gives us x is equal to positive 1, right? What about this one though? That one, we have to do this. We have x squared minus 2, and you just set it equal to 0, and watch what happens. We're going to add 2 here and add 2 here, and so we end up with x squared is equal to positive 2. And then what do? Take the square root here, square root here. And remember, whenever we're solving for x, we get a plus or minus. So we end up with x is equal to plus or minus the square root of 2. And so we have basically 4 zeros. There's 2, there's the third one, and there's the fourth one. This is the principle of zero products. Now aren't these fun? Okay, so what you want to do is like number 8. I'll help you get started at number 8. Is in order to use the principle of zero products, you need to have 0 on one side. So that's the first step. You want to move this to the other side. Okay? So the way we move 12x is to add 12x to both sides of the equal sign. And we add 12x over here. And this gives me x to the 5th power minus 8x cubed. And then plus 12x equal to 0. Alright, do you guys see the next step? There's a common factor, right? There's an x everywhere. So I'm going to start out by factoring out an x. So I get an x here. And now do you notice this trinomial is similar to this trinomial? What I'd like you to do is spend a minute and see if you can finish. You want to do this, factor that, you'll have this x sitting here equal to 0, and then you need to do the principle of zero products. You need to start setting each of these factors equal to 0. I can give you about 2 minutes. Well, why don't you try to wrap up this study guide? There's only a few more problems on the study guide. And then tomorrow we'll basically have a work day to work on some of these problems. And like I said, this assignment takes a while. So you probably want to do about an hour of it tonight and do another hour tomorrow. Okay, so this is where we'll stop.